All right, so let's now see what reminders to have for the coming week. Your written test number 1 result, written test 1 result, and the answer, I will release them either later tomorrow, Friday, or early Monday, the latest. You definitely get a mark and also the answers. And if you want to go over any part of the question, you're more than welcome to drop by my office hour in person. I don't normally deal with test questions over email, but if you come to me in person, more than happy to go over your answer and give you some feedback, right? So you can wait for my communication over e-class. Your lab number 1 will be due tomorrow, Friday, usual time, noon. And your lab number 2 is going to be released very soon. Okay, lab number 2 is going to build on top the technique. It's a different problem, but it's a different technique. Sorry, different problem, but the same technique about OOP. Especially, you have to use exceptions. So what we're going to cover today about how you can interpret some testing, it will also be relevant to lab number 2. Question?
For the labs, I remember you mentioned that you give full marks if we tackle, even if we can't get count.
Yes.
So if the case that we're working on a lab gets stuck, and there's parts of it that aren't finished, is that still considered?
Yeah, for the lab, even if you submit like a half completed lab, you will still get 100%. So the idea would be you'll be responsible for your learning, before and after the lab. So in the actual test, I will actually assume you have learned everything you're supposed to learn from the lab. But for the actual submission, just make sure you submit your best attempt before the deadline, and they got 100%. Right? Yes?
There's no feedback on the previous assignments.
So for lab 0, part 1, and part 2, I thought you're basically just following me, about the instructions. So I thought it may be a little bit kind of redundant to give you any feedback as long as you follow through. But for lab number 1, your practice test number 1 will definitely give you feedback, especially for practice test 1 that you took last Friday. Yeah, for sure. Yes?
So when I was doing lab 0 part 2, I realized that I submitted all the required source code.
Specific detail, let's talk about after class, right? It may not apply to everybody. Okay? All right, guys, any other questions before I jump into some recap? All right, guys, we're getting started, right? Please. Yeah, sometimes you might be thinking, I might just be talking very quietly. Jackie cannot tell. No, I can tell everything. Everything is sensitive, please. All right, so now let's do some very quick recap. So last time, we actually spoke about in very much detail of the exception. Especially, we talk about the catch or specify requirements. And we talk about execution flow, especially normal versus abnormal. Normal is when no exception has been thrown by the method call. But for the same method call, it might throw some exception, in which case it will be abnormal, in which case we have to know a different execution flow. And we're going to use this particular concept very much in the new lecture where we talk about testing, but we'll see. All right, and also we talk about the call stack, and we use it to really summarize about how the catch specify requirements should be understood. And you can definitely refer to that part of the recording from Tuesday. All right, and then we talk about version number 1 for the example, version number 2, and version number 3. Especially for version number 3, none of the methods in the call stack, they try to handle the exceptions. Every one of them specifies it. In that case, the exception will be thrown to the console, as we actually explained and illustrated Eclipse last time. That will be the extreme. And we talk about more examples on the exception. We talk about circle, calculator, and we talk about some slight extension to it by using some Boolean variable so we can use a loop to make the program a little bit more tolerating for the user. That's something you also want to dive into the detail of the code. And we talk about the banks over here. And for the bank, we just got slightly more classes involved. But only 3 classes over here on the call stack, right? You also want to refer to the detail. And we spoke about how you can understand a method call like this, right? You got an array of accounts, go to a particular index that should really give you just a single account, right? So that's how we figure out the context for the caller. And we talk about this example here, and we talk about having multiple catch blocks. Whenever there is a new exception thrown, you will go to the matching one. That's where you will go, right? That was the last example we talked about last time. Any question from last time you want me to clarify, repeat? Anyone? If no, I will move on. Let's consider, we got two more things to finish off the exceptions lecture. Number one, let's now consider a small problem, which is a very practical problem that you might be interested in solving. Let me present to you the problem here. I'll give you guys some time to kind of conceptually sketch a bit the solution. So this is one of the library methods from the integer class. Hey guys, hello, hello. Please, when you guys talk, I can hear very clearly. All right, thank you. All right, so integer class, that's from the Java API, capital I, not the int class, integer. And we have a method called parseInt. So this method here takes a string input. And what does it do? It's trying to convert whatever user enter from the console, for example, and then convert that into integer. So that's why you see that it returns an int. And remember, we talked about static. So what does it really mean when a method is static? That means you can call the method with just the class name, integer.parseInt. That's how you use it. Let's see some example. And before that, you can see as part of the API for the method, over here it says throws number format exception. Right? So now we can choose to either handle it or specify it. But now in this case, I would suggest we try to handle it. It can be done in a very useful way. Let's take a look. That's just some example usages. If you say integer.parseInt and you pass the string 23, you can think about whenever you type something from the keyboard and use the scanner input, that next line, it's going to take the 23 you type as a string in quote. And if you give this to the parseInt, it's going to give you 23, integer. It will do the type conversion for you. Pretty handy. On the other hand, if you type, let's say, 23, or anything that simply cannot be converted into an integer, it's going to throw number format exception. So now, in your mind, you should already think about how the normal flow, how the abnormal flow should look like. So this is our little problem here. We want to write a small fragment of code that is going to prompt the user to enter a string, right? The string can be this one here, convertible to integer, or something that's simply invalid to be converted into an integer. And that's something we'd like to do. And maybe using a loop to say, keep prompting the user to enter a string until they have the very first string that's actually valid to be converted. That's something we'd like to do. All right, so now I'll just give you guys 30 seconds. Think about it in this way. If you're trying to call this particular method over here, how do you say, I want to assign its return value to some variable, int. But I need to handle two cases. Either the string entered by the user cannot be converted, or it can be converted. How do I kind of distinguish between them, right? Then think about it, and then I'll go over the solution with you. Only a very small fragment of code. And very usefully, this kind of execution flow, we're going to see them many times today, right? So hopefully, by the end of today, you will just feel more comfortable about this way. All right, let's now take a quick look of the solution. All right, so this will be the solution. I'm going to run maybe some test cases together with you. So you can see we are using a scanner over here and reading some input from the user, right? Oh, let me just highlight this one to you. This will be the Boolean flag pattern that we actually saw earlier last time, right? For this part here, I'm going to leave it to you, right? This is the same pattern, all right? So that's something you're supposed to dive into the detail for that circle calculator too and try to make sense out of it. If you got trouble understanding it, reach out. Okay, let's now focus on this particular method call, this one here. Integer.parseInt. You can see we got something called user input. User input simply comes from over here, which is what the user will type from the keyboard, right? That's something we did, I think, in Lab 0 Part 1. Now, the user may enter something like a 23, or they may enter something that just cannot be converted into integer, right? Either way. The idea will be the program wants to keep prompting the user until they enter the very first input that can be converted. Okay? Let's now try to run it. Let's now try to see the execution flow. So we start from here, number 1, number 2, number 3. And now, because valid integer is actually false in the beginning, not false will be true. So go into the loop. Number 4. And then number 5, the user is going to enter some input. Let's say 23, right, in this case. So it's going to be 23. We know that this is invalid, but let's see what's going to happen. And then we go to the try block, and then number 7. Now, the user input over here is going to be that invalid string, 23. According to the API for parse int, it is going to throw number format exception, right? So what's going to happen is this one here is going to have the number format exception. So we are not going to go for the remaining part. It will be disrupted. So we go to here, catch block. And then number 9, we're going to tell the user it is not a valid integer. You may try again. And at this point, the Boolean flag that's initially false remains false. And then we might reach the end of the catch block, and then we might reach the end of the while loop, and then we go back to its header, number 12. Check again, not false. And then let me finish this one, and then I'll take a question, if that's OK. And then we go to, OK, for the second iteration, I'll use different color. So 13 over here, OK, initialize the scanner. Number 14, ask the user again. Let's say this time they enter 23. So it's going to be 23 from the user. So 15, 16. And now it's going to be 23 as the user input. And this time, the parse int method is not going to throw that exception anymore. Instead, it's going to do the conversion, and this user integer variable is going to be successfully assigned to be 23, right? And after this, we should really continue without being disrupted. So we go to 17. That one there is going to set a valid integer to be true, all right? And we're going to bypass. Of course, we can reach the end of the try block, bypass the catch, bypass this one here, and also bypass this one here. And we're going to reach the end of the for loop, while loop, sorry. So this will be 19. OK, this will be 19. And then finally, for 20, it's going to be checking the loop header again, final time. And remember, the valid integer has been set to true. So not true is going to be false. So we exit from the loop, and that'll be it. All right? This is a very nice program here. It kind of combines the Boolean logic that we explained last week. Sorry, not last week, Tuesday. And then we also try to combine with our understanding about execution flow, either abnormal versus abnormal, right? You just have to be very clear when you are expecting the exception to occur. Under what circumstances is it going to occur? And how do you interpret the flow? Okay? All right, any question about this? Parse int. Question?
For the catch line, with
Yep.
the brackets, you have a specific type of exception. Does that mean it will only catch that exception and it won't?
That's correct. So the question was, according to this catch block over here, because it specifies number format exception E, so that means only this one will be caught. Let's say for whatever reason, if somehow when you try this try block over here, something else got thrown. In that way, you'll get some different runtime error, which we don't consider right now. But typically, what you should really make sure is for every method call you're making, you want to make sure there is a corresponding catch block if there's some exception you might be expecting. That's what you should put.
Is it bad practice to use like a catch-all method? Where it's like, not catch-all method, sorry. I remember from...
You mean so just to say catch exception?
Yeah, it's just like it just caught every exception.
Yeah, it's not a good practice. Maybe it's a very, like a safety net at the end, but let's not worry about that too, because that one requires a little bit of knowledge about inheritance. So I would say for now, the good practice would be, for whatever method call you have in your try block, you may have multiple ones that might throw different kinds of exception, in which case each one of them should really deserve a separate catch block. That's what you should do. Question?
In this case, the integer class is the one that builds the exception to us, right?
Yes, that's correct. So if you look at the API, I don't have it here. If you go back to the slides over here, you can see as part of the API for the method, it says throws. That's a specified option. Right, that's why. So when you can Google this particular method here. If you go to Java API page, it will show that it shows you it's going to throw this exception.
So, what does the E represent on the exception?
Okay. Here, right? Okay. Think about the way you can think about this is you're almost like a declaring some method parameter, a bit like that. I'm saying that I might be thrown this particular exception, which I will catch. Within the scope of my catch block, I may want to do something with this particular exception that's being thrown. In that case, I can say, for example, print line E. I can say E.toString, something like that. So you can still refer to it. Yeah. But you don't really have to use it. Yeah. Good question. All right, any other question about this? Yes?
Is it possible to do the while loop inside the catch instead of having it like
Okay, the question was, is it okay to do the while loop inside the catch? I would say programmatically, it's absolutely okay if you try the whole thing into over here. Yes, to say, I want to try, I see what you mean. Basically, you want to try to be outermost, and then put everything inside. Uh-huh. I would say typically, for the try block, you want it to be as small scope as possible. Because somehow I want to isolate just this particular line, to say this line may throw the exception. But somehow if you wrap the whole thing into a try block, it will still work programmatically, but it could be potentially confusing. Because you're saying, my whole fragment of code, let's say 100 lines, it might throw some exception, but we don't know where. It might work, but just not as good practice. Very good question. I like that question. All right, so let's now move on. So the last thing I want to talk about very briefly, okay? So that's the slides I skipped in the beginning of the exceptions lecture, which is we now understand reasonably well about exceptions, which the essence of it is about the catch or specify requirements. But what if we don't really have that requirements? Let's say we just want to print out some error message to the console. What's going to happen, right? I just want to explain to you the essence of this comparison here, and you can also read the slides. Okay, that'll be the last thing to discuss. Let me show you right away. Let's now revisit our circle class. Okay, so got our circle here and circle calculator, and let me remind you very quickly. So we got circle calculator, and then we are in the main method. So circle calculator dot main. And also we got circle and then set radius. So we got circle dot set radius, right? Which is here. Circle set radius. The only modification I made was this line. When the radius is negative, rather than throw new negative value exception, rather than doing it, I'm only printing out something to the console to say something has gone wrong. All right? So now I'm not really using exception. What I want to point out to you is you want to know what's really the consequence of doing this as opposed to exception. Consequence number one. No more catch or specify requirements enforced on the callers in the call stack. No more. In some ways, simpler, much simpler. You don't have to worry about to what extent should you actually be subject to the catch or specify requirement. That's number one. Number two, in some way you can think about this might be advantage because things will be kind of easier because you don't have to think about the catch or specify requirements anymore. But it comes as a price. The price is the caller of this method. I'm talking about the set radius method, which is where the error was originated. The error originated is no longer obliged to handle the error. I will show you what that means. All right, so 2 points, guys, to really remember. Number one, let me repeat. when you actually have replaced the throw new exception by just printing out some message to the console, the advantage could be it's much simpler because no catch will specify requirements reinforced, no more. That by count with the price. The price will be now any subsequent caller of the circle.setRadius, for example here, circle calculator main, the caller, they are no longer subject to the catch will specify requirement, meaning that they don't have to do anything to handle the error. Let me show you. Let's now try to trace the code to see. Now I'm at a caller, circle calculator, and main. Let's now try to trace that very quickly. If I try to create a circle objects, and now I try to set the radius to be -10, all right? So this method I know is not, of course, it's not going to trigger any exception anymore. There's no exception. It should be trigger some error conceptually. So now when we go to set radius over here, and then we know it's -10, so -10 less than 0, we're going to execute this line, right? That one basically is going to print out something to the console to tell the user you enter some invalid radius. Up to this point, it is good, right? It does signal the error to the user as, by some means, all right? But here's a problem. After this line over here, is the flow going to be disrupted like in the case of exception? Not really, all right? So what's going to happen is we are still going to go ahead to the next line. This is already conceptually wrong because given that the set radius already told you, the callee told you this is an error, why are you still proceeding your calculation of the area given that the radius is invalid? Right? So that's really the drawback for using console messages. You don't have that disruption of the execution flow. Let me write it down. So this one here is, given that the callee, which is a set radius method, already signal an error to the console. And error. Caller still proceeds to calculate the area. And what's going to happen is if you try the source code I made available to you, if you tried it, it's still going to print out to say the area for this particular circle is something. But that's already wrong. The user will get confused. So ultimately, they're going to see two messages on the console. Number one, they're going to see this one here to say invalid radius, right? That's the error message. And the number two, they're also going to see area is some value, contradicting, right? You're telling me the radius is invalid, but you also tell me what the area is. They should be kind of separate, either one, but not both. So the essence of the difference between console tester, sorry, not console tester, let me say it again. The essence of the difference between exception handling versus console messages is, in the case of the console message, there's no more catch will specify requirements, but it's going to allow the caller to get away from being disrupted. They can still do whatever they like, which doesn't make sense in many cases. All right? All right, any question about this? All right, hopefully that makes sense to you. Of course, the conclusion will be use exceptions. That will be a much better way to actually handle. And the second one, the same example, right? The bank. I just want to point out to you that's something I would encourage you to also try it out. You can see we still got our bank application main method, and we try to call bank withdraw from. And in that bank withdraw from method, we try to call the accounts I, right? The account class withdraw. And now in the account withdraw method there, right? That's a call stack, right? And this is what we have. Rather than throwing that invalid transaction exception, we're now going to print out some message over here. So it's going to be the same impact. Let's say I'm trying to, withdraw minus 5 million from my account, even though there will be an error message printed to the screen, but it will still do it. That's not good, right? So you want to make sure whenever something goes wrong, the caller should be disrupted right away in the exception. Any question about this? I think that this final part here is also important. It's really important for us to know why we are doing things one way but not the other. Right? You want to understand what could be the potential advantage versus disadvantage. And that will be the end of the exception lecture. All right? Any part you want me to clarify before we move on to a new lecture? All right. Let's now do that one. All right. Now we're done with this. Let's now do a new lecture. This one here shouldn't take, hopefully, only today and a small part of Tuesday. And we can move on to object equality. Hopefully, you can finish that lecture before the reading week. So I'm going to talk about test-driven development or regression testing, which I briefly mentioned when we walked through the syllabus. Today, I'll make it very precise and visual to show you that's a very good practice of software engineering for you to apply, maybe from your lab number 2, or you have been doing it already. Let's see what we should learn in this lecture, and I'll switch very soon. We want to use a running example like a bounded counter, basically like an integer counter. It's going to start from 0 all the way to 3. If you go below 0 or go above 3, it's going to be considered as exceptional, right? That's something we'll see. And we want to see how we can have some test strategy. So this is not really like a software testing course, but I can give you some intuition about if you have some very simple single variable, how you can try to come up with all the possible test cases accordingly. You might find it useful for some of your lab exercise, some parts of your lab exercises. And the next 2 points are very important. I'll talk about them together. We learned about normal versus the disrupted execution flow. And now we're going to put them in the context of JUnit testing. Whenever I try to write a JUnit test method, there should be certain intention or expectation. What do I mean? You might be thinking that whenever an exception is thrown, it should be considered as a bad thing because something bad happened. However, when you are doing testing, you might be expecting some exception to be thrown, in which case the test should really pass instead of fail. It might sound very weird, but that's something we'll deal with either today or Tuesday. But I just want you to make sure when you review the slides, make sure you also revisit these 2 points to see how they work together. So this is what we talked about so far about normal versus disrupted. But today we'll put in one more thing in the context about writing test cases. Okay, that's important. I'll clarify a little bit more. And then we're going to talk about regression testing. That's also a very practical topic for you to apply in your side projects or project in this course. Let's now see the running example. So we got 2 kinds of exceptions for the counter, right? So one would be, let's say somehow maybe the value for the counter is too large, right? Let's say you go above the upper bound, larger than 3, for example. So value too large exception. Also, we got another symmetric one, value too small exception. For example, it might go below its minimum, in which case maybe -1, right? And these 2 exception classes, of course, any objects instantiated from them, if they got thrown, it should be subject to catch with specified requirement, right? That's something we just talked about. And it may specify or it might catch. Let's now see a very quick review, and then we can move on. So about the specify option over here, in which case we just want to propagate to the caller. So there are 2 scenarios for us to use a specify option. So typically in the origin of the exception, we will use the specify option. So this will be the origin of the exception. And then in that case we say throws, right? That one we know. Also, let's say there is a caller, let's say C2.M2. And it is trying to call a method which itself specifies already that it might throw the exception. In that case, we also are subject to the same catch with specified requirements. In this case, we can also choose to specify. That's why you see specified over here. Right? So 2 scenarios, basically, that we spoke about. Nothing new yet. What about catch? Let's say over here we are trying to, let's say under C3 main, we are calling this C2 and then M2. And this method here may throw that particular kind of exception. In that case, we choose to catch. So we have the try and catch block to wrap it. And in this case, since we got try and catch, we don't see anything here anymore, right? You choose either catch or specify. You don't choose both. So far, it's only review about catch with specify. All right, before that, let's now take a look at the slides. Catch, the specify, and also the catch, right? We spoke about them. Let's now take a look at some very simple partial implementation for the counter that we're going to deal with. And then I'm going to give you some takeaway, for good practice. Let's say we have a class called counter, and then we have 2 integers over here. And notice the keywords I'm using. Number 1 is static, meaning that they're global. They're shared by all the counter instances. And final, you may have seen that before. Final simply means the value once initialized cannot be changed ever. So they're called constant, right? Because the lower bound and upper bounds never got changed. I heard that. All right, so you really want to make sure you understand how to use these keywords. So final static integer. And I simply initialize it to be 3 and also 0 over here. And we got some private attribute value here. Right? You can see here, only one attribute for us to deal with. And the value should be within the minimum and also the maximum. And we got a constructor counter over here. Right? Initialize to be minimum, just to make it simple. Initially 0. And we got an accessor, which will return the value. And that'll be it. So here's a takeaway from you. All right? When you're developing your Java classes, let's say in your lab, you don't necessarily have to wait until you have finished everything before you can start writing the first test case. The truth of the matter is you should really try to write test cases whenever you are clear about what you really want in your application. Right? That's the takeaway. And let's now see how we can do it. Right? So the requirements we have for this class over here is the counter value must be within the lower and upper bounds, right? Like here, right? You can ignore the diagram here just for now, sorry. Ignore them just for now, okay? So this will be our requirements. The counter value should be larger than or equal to inclusive, the minimum value, less than or equal to the maximum value, right? That's the only requirement we have to stick to. Simple enough. And let's now have a quick question for you. Oh, principle first. You really want to start designing a test strategy, which doesn't need to be specified or written or expressed in Java. It can be just on paper or conceptual, like a state diagram I'm going to show to you. You want to do this even before your code is even started or even before the code is completed. You want to start testing as soon as you can. That will be some takeaway from you. Easy to say, but difficult to do. Because I know you guys, like me, when I was like a student, you definitely want to start coding right away for as much as possible, but the good practice is you may just want to interleave testing and code development together, right? But anyway, that's the principle. Now here is my question for you. Let's say we now want to get some idea about what kind of test cases we want to turn into Java. So here, how many possible error or exceptional scenarios are there for this counter example? Given that we want to stick to this particular requirements. How many? One more assumption. There are only 2 possible ways you can update the counter. Either you want to say increments or decrements, either way. Given that the counter must be within a range, and the only thing you can change the counter will be either increment or decrement. Now, how many exceptional scenarios are there? Tell me one. Say it again? It's below the minimum value? Yes, but whenever you talk about exceptional scenario, below minimum, I agree, but what method is being called? Okay, are you suggesting that if currently, for example, if currently the counter value is -1, and I try to call decrements, then I should really maybe throw some exception. Should that be earlier? Because isn't -1 already invalid? Should you maybe call earlier? What about when counter value is equal to 0? in that case, let's say when the counter value is 0, I try to call decrement. Should I already throw an exception?
After you call decrement initially.
After or before?
Well, 0 is valid.
0 is okay. 0, I agree. 0 is okay. It's still satisfying this. But if you don't really throw an exception on this decrement here and let it execute it, it's going to decrement the counter value from 0 to -1, which is not good. You should never try to let the counter value go below its minimum. So you should really do some precautionary measure to make sure whenever I call the decrement over here, if it has the potential to cause the value to go below its minimum, you should stop it right away. Right? And similarly, for the, maybe that's what you guys wanted to say. For the maximum, similar. Let's say if currently the value is already the maximum, which is okay, but you try to increment, that's not good, because that's going to cause the value to be maximum +1. Now, so far, no Java code has been written. Right? Let's now discuss a little bit further. We know that there are 2 exceptional scenarios. And now we want to make it a little bit more complete. Let's consider all the possible scenarios, given that our range of the counter is pretty small. So we can do some exhaustive analysis. Okay? So what I want to show you is something called state diagram. So what do I really mean by a state? Think about a state is more like a combination. A combination of the variables of interest. In our example over here, there's only one variable, like attributes in the counter class, which is value, right? There's only one. But let's say if you go back to your lab number 1, go to later your lab number 2 or subsequent lab, you got tons of variables in your class. Do you have to put all the variables into analysis each time? Not really. Depends on which one you want to focus on testing. So that's kind of the idea. But let's now make it simple for now. Let's say the only variable of interest is theta value, the value attributes. Now we want to be exhaustive about how the value might change throughout the lifetime of any counter objects. Let's take a look. In the beginning, usually put this arrow here pointing to the leftmost circle. That means initialization. That means when you first create objects, the counter objects created. And we know that initialization is going to make the value simply 0. Right? That's what we saw in the constructor. And we assume that the only 2 methods we may call to update will be increment and decrement. They're both mutators. Right? Returning void, but they're going to do something to change the attribute value here. So now, how do we, and what can be the allowable values for counter? Because it's going to be in between minimum and maximum. So it can be 0, corresponding to minimum, and maximum will be 3, and also 1 and 2 in between. 4, right? So the 4 circles over here are the 4 possible legal states for the counter. But how do we kind of move between them? How do we go, for example, go from 0 to 1? Or can we go from 0 to 2? Not really, right? Because we can only do increment by 1, right? So now we want to think about how to transition between them. I'm going to do it here. For example, let's say currently the value is 0. I can definitely try to call increments and go from 0 to 1. I can go from 1 to 2 by calling the same method second time. Calling the third time from 2 to 3. So far, I'm still in the legal range. Once I reach the maximum, I may choose to decrement from 3 to 2. I may decrement from 2 to 1. I may also decrement from 1 to 0 again. Of course, you can do as much as you like. I can say increment, decrement, increment, increment. I'm still in a legal state, right? As many as you like. There are infinite number of possibilities because we got a loop in the diagram. But I'm missing 2 scenarios, which are exceptional, right? Which we talk about. Which will be, let's say 3 here is already the maximum. Now, if I try to do, if I here try to do increment again, it is going to be exceptional, right? Because in that way, if I allow it, it's going to go from 3 to 4, which is not good. So this one here should be exceptional. And symmetrically, let's say I'm now in the minimum value. If I try to do decrements over here, if I allow it, it's actually going to go to -1. So I shouldn't really allow it in the first place. That's also exceptional. So in total, how many test cases should we devise? 1, 2, 3, 4, 5, 6, 7, and 8. For this simple example, 8, at least. Okay? Each one of them somehow can be translated into a Java JUnit test method. We're going to do 3 of them in the lecture, but the other 5 can be done very similar way. That'll be exercise for you. Now we're going to do hopefully just 1 today. That'll be enough. I want to pose another important question to you. Okay? I said before 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to divide them into 2 categories. All right, let me do that first, and then I'll ask you a question. Category number 1, like here. Give me a moment. This will be category number 1. Okay, I'm going to put 1 here, which will be this one. Category number 1. And category number 2 will include this one over here and this one over here. Okay, they both belong to category number 2. All right, so now let me phrase my question here. Number 1 and number 2. And number 1 includes 1, 2, 3, 4, 5, 6. And for number 2, it includes this one here and this one here, right? 2 categories. Now, if I want to turn both categories into JUnit test cases, what would be the fundamental difference in terms of their intention or expectation, especially about exception? What would be the difference? Let me say it again. Might sound a little bit weird, the question. Let me say it again. I got category number 1, which will contain 1, 2, 3, 4, 5, 6. I got category number 2, which will contain 1 and 2. If I want to turn each categories into a set of JUnit test cases, JUnit test method, what's going to be the fundamental difference in terms of what the test expect to achieve? All right. Start with you first.
So for category number 1, you'll be expecting result or value.
Okay, because maybe from 1 to 2, 2 to 3.
Exactly. And in category number 2, you will be expecting an exception.
That's perfect answer. I like it. All right. So your classmate, oh, sorry. Was not intentional. So your classmate said exactly the right thing. All right. So for category number 1, we definitely will expect the update to be taking place from 0 to 1, 1 to 2, or maybe from 2 back to 1. And the important thing is we do not expect any exception to be occurring. All right. So now let me write it down. So here for category number 1, no exception expected. On the other hand, for category number 2, let's say I try to increment when my value is too big, or when I try to decrement when the value of the counter is too small, I will be expecting exception, right? That's the fundamental difference. Exception expected. Let me say one thing further, okay? Let's say I'm trying to run test case in category number 1. Let me put a star over here. Right, category number 1. Let's say I run a test in category number 1. And exception happened. Either value too large or value too small. Should that be considered as a pass or fail? For example, when I try to test incrementing from 1 to 2, I somehow got some exception. Should that test be considered failure or pass? Failure, right? Because I don't expect exception to occur, all right? That one there would be failure. If no exception happened, that means pass. That's for category number 1, right? I'm going to do something very similar for category number 2, right? It is very important to understand what I'm trying to lay out over here, because once we get to a code example, it all depends on this understanding, okay? So one more. Let me try to annotate for category number 2 over here. Okay, I'll put it here, just side by side. I'm going to run a test in category number 2. And let's say value too large exception. Let's say I'm doing this one, for example. Or value too small exception, whichever way that applies, happened. Now, should that be considered as a pass or fail? Pass. All right? Because I do expect them to happen. All right? Now, it would be a pass. Symmetrically, if no exception happened, in that way, it's going to be a fail. So you can see that when an exception happened, depending on which category we are at, it might be either considered as a pass or fail. What does that mean? That means when you set up your JUnit test method, you got to be very careful about how you structure the exception handling. If you structure them wrong, then you might still have a test case, but that test case turned out to be logically incorrect. That's something we want to watch out for. All right? So this page over here really tells you there are many things about testing you can already try to sketch and understand without writing the actual complete code. That's a very important mindset to have. Right? All right, quick recap. So we have the different test cases, 8 in total, that we want to run or turn into Java code. And then category number 1, we do not expect any exception. You want to see accordingly what should be the pass and fail. For category number 2, we do expect certain exception to occur to signal the exceptional scenario for the counter. In that case, how do we interpret the pass and fail accordingly? Right? They're different. Exactly the opposite. All right, any question about this? All right, if you guys are okay, now we can move on. Okay, the counter, okay, let's talk about increment and decrement. So we have some simple implementation, right? I'll go over them with you. So this is what we spoke about the basic stuff. So now we got increments and we got decrement. But now it should be easier for you to understand what's going on. Okay? Let's say, for example, for the increment method, it is possible to throw value too large exception, which will correspond to this case over here, right? When it is exactly equal to the maximum. That's why you will see the if condition here. If the current value for the counter equals maximum, I'm going to throw that exception. Symmetrically, for the decrement method, I might also throw another exception, which will be value too small exception. And that one there will correspond to this part of the diagram. Right? You can see the value is already equal to the minimum, and I'm trying to decrements. Right? And it might be thrown. If there's no exception to be thrown for increment, I will do increment. If there's no exception to be thrown for decrement, I'll do decrement here. Right? Straightforward. But one important thing for you to bear in mind. These methods, even though they're simple enough, but I can tell you that this condition over here sometimes could be tricky to get right. For example, for me, rather than putting just equal, maybe I forgot, maybe I'm confused, I'll just put smaller than. Let's say, right? Now, can I just expect somebody to read my code and also realize this is wrong? Not practical. You need a good test case to really reveal or reject any error that you put into your implementation. So what we're going to do is we're going to clarify about the role for the software developer and also software tester. There are two independent roles that we have to watch out for. Whenever you're given some method, like an increment or decrement to test, you can never assume it will be correct. You have to find out what's wrong in the method, right? So that's the two methods we spoke about. You can read through the description. Okay, component of test. Okay, let's now take a look. And this part of the slide just gives you some example about how you can set up the test, but that's something we'll do anyway. Okay? And about pass or fail, that's something you can also try to. Okay, I'm gonna elaborate on this final bullet point. A test may pass if the expected outcome occurs. It may fail if the expected outcome does not occur. What does that mean? Let me visualize that a little bit for you. Okay? So let's say this is a very simple JUnit test case, right? You can see the test tag over here. And the name of the test is called test. And the callee over here is simply a main class and then get value, right? Let's now try to clarify the terminology here. Number one, you can see that this one here, 23, we're doing some assert equals. This 23 here is called the expected value. And the method over here, test, the JUnit test method, is called, I just call it test method. We got another category of method. Another method is actually here, which is a callee. This method over here, we call that the method under test. Under test. Right, just this method here. And the fact that we're calling this accessor here and get its return value, the return value itself is called the actual value by the program. So the actual value may be correct or may not be correct. We don't know. It depends on what the expected value is. So if you try to also box this, the return value here is called the actual value. Return value is what we call the actual value. Now, how do we kind of visualize these components together? Right? Let's now try. Let's talk about the method under test first. Think about for the method under test. So the method under test. And in this case, it could be the get value. That's something we would like to test, which may or may not be correct. And typically, the method is going to take some input. In this case, of course, it doesn't. But in general, it might take some input, right? Or maybe there's something that occurred before that method call. You can think about this more like an input too. So there will be some input, and then they're going to produce some output, like a return value. So this will be the actual output. And then I'm emphasizing it's the actual one, okay? Whatever code you're given, the actual one. So this will be the actual output. So that's simple visualization for the method under test side. You got input, you got output. How do we put the test method into play? That's important. That could be the slight confusion you might have. The way I understand is like this. So let's say we put the test method, which would just be another box, which will also take input and produce output. Test method. JUnit test method. And in this case, it's just called test. Or it can be test products, test assessment, whatever, right? And we're going to have inputs into this test method. What inputs do we have? We got 4 different inputs. 3 of them will come from the method under test. Let's take a look. So number 1, you want to have the input to the method under test, and then the method under test itself, and also the actual output that's produced. All right, all together. And then you also got something called expected output. That would be something to compare against. So this will be the expected output. Right, so it's important to see we got expected versus actual. And once you compare these two, if they match, it's going to pass. If they do not match, it's going to fail. Right? That's how you understand. It may either pass or it may fail. So here is one example. I'll give you two. Example number one. Let's say your expected output is the value too large exception should occur, but it did not occur in the actual output. In that case, fail. Example number one. The value too large exception should occur, and it does occur. In that case, pass, etc. Right? You always try to match expected versus actual. If they match, pass. Don't match, fail. All right, so that's about some conceptual clarification. And then, no question, I guess. All right, let's now move on. Okay, about JUnits, very quickly, just a few more points, because you guys actually have been using JUnits since day one, so I don't need to repeat too much. JUnits is a very good way to automate the testing. So whenever you write individual test cases written down, every time you want to run them all, just right-click and say Run as JUnit application. So pretty straightforward, automated. And what if you want to use system out of print line as tester? In which case, you got to print out the text to the console, examined by your eyes to see what's wrong. That's not automated. And you can derive the list of test cases like what we did earlier, right? Like this diagram, derive them, and then transform them into JUnit test case, which we'll do. And each test method is like a caller, because we're calling some method that you want to test. You may try to use either illegal way, right? Success, failure. That's basically what we just mentioned, right? So for this bullet point here, I would suggest come back here to these two big bullet points after we have seen all the three examples, and then you can revisit. But these are principles. Regression testing. Let me do this illustration here, and then we'll take a short break. Okay, regression testing. Let's now take a look at the diagram here. All right, that's a diagram. It's basically a workflow that maybe you have been doing a bit. I kind of force you to do it since you're doing your labs in a particular way that's really going to kind of force you to do regression testing. But let's see what's happening here. Let's start from this box over here. So this box contains all the Java classes you're developing. Let's say all the model classes. All right, and then you can see self-directing arrow, meaning that we're just changing these classes only. And you might change for extension, you might change for maintenance. That means it's really an ongoing process. You don't say, after several days of development, I'm done forever. Not really. Sometimes maybe you have to fix the bug. You may want to add a new method, new functionality, or maybe you want to refactor that to get rid of the smell by using helper method, right? There are many things you can do to improve your code. So it's a really ongoing process. It's even more the case in reality. And the next step would be, based on the Java classes I'm trying to develop, I can try to derive. So derive over here is not necessarily, this can be a sketch. Or it can be some strategy, like what we did earlier, right? You basically just say, given my Java classes and my understanding of the problem, I'm going to have some test cases that I plan. And then I can specify them into JUnit test method, right? Once I got my method under test and the test, right? Remember I just spoke about it over here. The method under test and the test method. And then I'm going to combine them together, pass them to the JUnit framework. Now, the result can be either fail or pass. Each one of them has important implication. Let's say the case of fail. Oh, let's say pass first. I think that'll be better. What does it really mean? When I get a green bar, that means my software is, I put in quote, correct. Software is correct with respect to the coverage, and quality of the tests. Let's say I got 10 test cases. Somehow they cover every possible input scenarios. In that way, it's a very good coverage and also quality. On the other hand, I might have 10,000 test cases, but it's just a copy and paste from each one of them. In which case, I'm not really testing a very big coverage and quality is pretty low. So it really depends. So that's why whenever we talk about correctness, it's kind of relative. Depends on how good the test cases are. The more tests and also more coverage, that means more confidence with the correctness. So a good example would be, let's say your lab number 1, you found that your developed Java classes pass all the starter tests. That's good. It's a good starting point. You can say it's correct, but only with respect to the starter test. So you might still be subject to the test of the grading test, which I'm going to put on top. So you should really think about it. It's more like a spectrum about the correctness. All right, pass is actually rather good. So that means you should always try to add more test cases. All right, that's the conclusion from this branch. Always add more. So you can be more assured that your correctness is really good. What about failure? This is actually more important to realize. Whenever you got any failure, that means the latest change to your model class, let's say to the model classes, introduce an error. Let's say this. Let's say I got some green bar right now. And then I go back to my Java classes and I do some extension by implementing, let's say by fixing a bug, which I believe is a bug, right? I did some fixes. I rerun all the test cases, but now I actually got some red bar. What does that mean? That means the change I made introduced an error. What should I do? Go back to that change and do something about it. And this tells you that you should really try to run this JUnit test cases as often as you can. Incremental developments. Incremental developments. Meaning that rerun all the test cases. I wouldn't say after each line of change. That might be too much. You don't really need to. Maybe after every logical and small unit of change. Maybe after a block of code has been implemented, maybe after a small method has been implemented. Each small logical unit is implemented. All right, so that'll be the advice. All right, so that's about regression testing, really meaning that you want to really start with something small for the test cases, keep adding, and keep using it to define the correctness of your software. The more, the better. And the more coverage, the better. Okay. Why don't we take a very short break by taking attendance, and then we'll resume. All right, in the final 10 minutes, I would suggest let's skip some very routine kind of stuff, which I can read over a bit, maybe on Tuesday. But I would really love to talk about the very first example to let you struggle a little bit over the weekend. I think that's necessary to have that gap before you come back on Tuesday. Let's do that right away. So what I want you to look at is this one here. All right, I'll walk you over. Oh, by the way, the slides, I was still doing some final, like a major revision this morning, so I'll post it slightly later today. Okay, anyway, let's take a look at the test together, this one here. So we have a test case over here. You can see it's JUnit test. It's called test increments after creation of the counter. All right, so we are creating a counter here. Initial value should be 0, minimum. And then we are asserting that the return value from get value should be minimum value. Straightforward. And we're calling this method here, which may or may not throw the value too large exception. Right? If you recall the implementation from the earlier, you can look it up. I can tell you. Oh, I'm going to write it down. May throw value too large exception. This is also why you have the corresponding catch block over here. All right? And now, what you have is, you got, now a question for you guys. I'm calling this particular method. If the value too large exception occur, how should the execution flow go? If it occur, it's actually going to go to the catch block over here. So this is when the value too large exception occur. In that case, we say fail. By the way, fail is one of the Java JUnit assertion which fail unconditionally, fail the test. Okay, I'm going to talk a little bit more about fail on Tuesday. So this will be possibility number one. Possibility number two. Let's say this method over here did not throw this value too large exception. In that case, it's actually going to proceed to the next line. In which case, we are just asserting that you have really incremented from 0 to 1. Right? So we got two possible flow. So that's the setup for the test. So when you go from this one to this one here, this will be number 2. So this is when value too large exception did not occur. 2. Now, why is the test set up this way? Now we want to understand. All right? Let's try to see. Let's say we are trying to call the C dot increments over here, and at this point, the value is simply the minimum, which correspond to, if you recall the diagram here, you can see the value over here is the minimum, and we are trying to call the increment, and this one should be category number 1, which means it's a normal case. It should not trigger any exception. In this case, we do not really so this will be category number 1. So now we don't really expect any exception to really happen. If it really happened, it should fail, right? That's kind of link back to where we understood, how we understood the problem. Let me go back here. Let me talk about another thing. Now here's important. How do we actually got this different execution flow at the runtime? It depends on whether or not this method here is correct. Okay, what do I mean? So we got this particular increment method here. Let's say this. Case number 1, if it was implemented correctly. If it was implemented correctly, that means it is not going to throw the value too large exception, number 1, and also number 2 is going to increment. Imagine that you're being passed this particular method by one of your team members. They said, I'm finished with this particular method implementation. Can you test whether that's correct or not? If it was correct, these will be the criteria. It should not throw the value too large exception, and also it should really do the increment, which is exactly what we're doing over here, right? We're checking to see if that has done the increment properly. Another scenario will be here. What if the method that's being passed to you for testing is implemented incorrectly? That one simply means, number 1, it did not increment. Number 2, also it throw the value too large exception unexpectedly. Right? So that's something I would like you to understand first before we trace the code. Let me recap very quickly, and then we'll see some quick concrete example. The method being passed to you may either be implemented correctly or incorrectly. According to the setup over here, we're saying that when you try to call the increments over here, if the exception was thrown, that should be considered as exceptional because you're only trying to increment when the counter value is 0. In that case, we should just fail, because the exception happened unexpectedly. Otherwise, if you are able to go from the increment method call into the next line, that means the exception did not occur. which is what we expected. In that case, we check further to make sure the value has been incremented. Right? So these are the two execution flow. You can struggle through a little bit over the weekend. Let me do final 1 or 2 tracing quickly. Okay? Now let's see. This implementation for increment is actually correct because you can see the equal over here, right? Let's now trace that very quickly. Now I create a counter objects. I will try to make sure it is equal to minimum value. It is, right? Get value which should just be 0 initially. I go to the try block and I try to call this method here. At this point, see the value is equal to 0. And let's now step into the increment, which is assumed to be correct, actually correct. And when we go there, let's say number 5, and see the value, we know that it is 0. Equals the maximum value, that's correct implementation. Maximum value is 3. 0 equals 3, false. So we don't really throw the exception. That's good. That's what we expected. That's why it's correct. And then we'll go to number 6. Number 7 is going to increment the value from 0 to 1. So this is why after executing this line, since we don't have the exception, we're going to go for number 7 here. Assert equals c.getValue should now be 1. After this, we'll go to the end of the try block, bypass the catch, and then finally we get to the end of the method, like here. Now, here's one important thing to let you know, right? A good test is not enough just to tell you pass when you are given some correct implementation. You may not be given correct implementation all the time. A good test means when you are given some incorrect implementation, it will tell you, I reject, I fail, which we're going to see. Oh, final 2 minutes. This one here is, let's now make some error here. Let me now, rather than equal, I'll say less than. That's wrong. Let's say that's what you're given. Somebody made a silly mistake. All right, let's now do that quickly, and then we're done. So, number 1, number 2, so far so good. The initial value is still 0. Number 3, try block. Number 4, we try to increment. At this point, see the value, it will be still 0. We step into the method here. So number 5, we check the condition. See the value is 0, and maximum is 3. 0 less than 3. True. And we are actually going to mistakenly throw this exception. So that'll be number 6. The rest will just be bypassed. That means this, upon this point here, we're going to bypass this guy here. And then bypass this and go to the catch block. So that will be number 7. And then number 8. And this one is going to fail the test. So this will reject the unexpected value too large exception by failing the test. I got just 20 seconds. Let me recap, right? That's something you want to think over the weekend, right? And then I'll let you go. So think about this particular example here. So now the same test, but the implementation may be correct or may not be correct. Now, in the case of the correct implementation, your path should really follow the execution flow such that it's going to pass. And when you're given the incorrect implementation, in this case, it's going to throw some exception unexpectedly. In that case, it's going to actually fail the test over here. Right? Think about these 2 scenarios, and then we'll try to go back to some background and then finish off the example. All right? Thank you.